This is the basic UI overview for the Shade MFM. So when you first start the application, you'll see something like this. You'll see the actual simulators in the center, and the main UI we'll be discussing is on the left. The UI elements are actually multiple windows. You can move them around how you wish. This is just the layout that I prefer, but you can kind of pick your own. You can collapse windows by double-clicking on them and opening them up. So if some of these aren't useful to you, you can just kind of close them down. So the first thing you'll notice is the control panel on the top, and this is mostly what you'll be operating when you're doing runs of the actual simulation. The first simple button to click is Run, and that will just run the whole speed, the simulation. Here you see that you can switch the run speed. So for example, speed of 1 is, you can kind of watch that, and then a speed of 4 is 4 times faster and 8 times faster and so on. And you can reset the simulation, and that will go back to the beginning, and you can hit run again to proceed. You can also hit step if you want a single step through the simulation. So single steps are single GPU steps rather than single events. Because the GPU is simulating many events in parallel, you can only really step. The finest granularity you can step is kind of all the events on the screen that might fit. Potentially in the future we can add an event stepper, but that's more complicated on the GPU. And sometimes it's just convenient to be able to reset and run at the same time if you're sort of testing runs. One thing you'll notice is that the runs are actually deterministic at the moment. So later on we'll add a seed so you can change the actual run. The next thing you'll see is the size. So here you can change the different sizes. This is a very small grid, medium grid, and large grid, and so on. You can get very, very large to the point where you can't even see the fork bomb in the middle, at which point you might want to zoom. And so to zoom, you use the mouse wheel, and you just scroll up to zoom in, and then you can scroll back to zoom out. You can also pan when you're zoomed in or whatever. You can click the right mouse button and pan around to move the screen. One useful thing is if you click the mouse wheel and you're zoomed in, it will zoom you back out to get you an overview. And then if you click the mouse wheel again, it will take you back to your current zoom level. So that's handy. For example, if you're very much zoomed in on this left side of the fork bomb, you can quickly click, zoom way back out, click again, and you'll zoom in the right hand side of the fork bomb. So that's a good way to kind of navigate around if you have a comfortable zoom level for the size of your world here. One thing you'll notice is that depending on the size of your map, of course you can set different speeds. So 256 might be an appropriate size speed for a 128 by 128 map, but if you were to set it to a 2K map, then it will crawl. So for larger maps, you probably want to keep these relatively slow. The other thing to note is that the AER, which is kind of your average event rate, your speed at which this whole thing is running, may not actually change if you sort of request to go at faster speeds. And that's because you're already at peak capacity of your GPU, so it's just not going to go any faster. So for this large grid, for example, this 2K grid, it doesn't matter what speed you set it to, it's already going as fast as it can. But for a 128 grid, you'll see that sometimes it actually drops event rate, and that's because your GPU, modern GPUs will throttle down when they're not under heavy load. So the GPU noticed that it was on a heavy load a second ago when it was running the big grid, but now it's not, so it's actually dropped clock speed. If I then speed this up and go faster and faster, your AER will go up. Which, if you think about it, a little weird, but that's just because the GPU is throttling up to match the demand of what you're asking for it. And you'll see that it'll peak probably around 64x. You can see again it saturates, and it won't go any faster than that. AER will stay the same. The other things of note is the average events per site, which kind of gives you a notion of how many events have happened, and that's sort of time. And the step, which is how many steps the GPU has simulated. That's useful because there's this break at step function, which is handy. You can say break at step 1000, for example, and when you reset and you run, it stopped after it reached 1000 steps. That was kind of quick because it was running quite quickly, but you could see the steps are incrementing and it'll stop. And this is useful for debugging. If you're sort of trying to figure out a state of a simulation, you can start from the beginning, and like I said, it's deterministic. So every time you reset and run, the step will be the same. So you can use that feature if that's useful to you. So next is the projects pane. This is a direct mirror of your projects folder inside the ShadeMFM root directory. So right now we're set on the basic project. So we'll switch to the predator and prey project. And here you'll see the statistics. So now you'll see the elements are different now. So before in the basic you had res, friendly, fork bomb, and dreg. And if we switch to predator and prey, now you see that there's just empty animal and plant. So these are empty animal and plant things. And if you run, kind of go quickly, you'll see these bars will actually show you the proportions of the current elements. So you can see as the animals are dying out, there's more res that's being dropped by the animals, and then plants eat that up and grow, but then the animals eat the plants and things like that. So this is kind of fun to watch, especially for a larger grid where these things don't die out quite as quickly as on a smaller grid. Some of the elements are present in the project. So for example, dreg is always available, but there isn't any of it. So if you click the show zero counts, it'll show you all the elements that are in the current project, even the ones that are in the current world don't have any counts. And that's things like drag and wall and stuff like that. So usually you don't want to see that stuff because it's not pertaining to your current state. But if you want to sort of monitor how things come into existence, that might be useful. And next is the site inspector. So this is kind of a good state to be in, so we'll just break. So the site inspector, we'll zoom in a little bit so you can see it. Under the mouse, you can see a white square, and that's telling you which site this is currently looking at. So as you hover around, you'll see the site inspector is changing. And so right now, for example, I'm hovering the plant. Here I'm hovering an animal. Here I'm hovering an empty site. Here I'm hovering a res. You can click, if you click the left mouse button, it will lock that site down, and then you can navigate the UI while this pip sort of stays in place. So you can change different things as that stays the same. You can look at the different debug information. So this particular atom is an animal type, and animals have a hunger data member. So here you can see the declaration. So you have an unsigned 7 hunger, and its current value is 63. You could also see the exact site location, which might be also useful for debugging. So this is the basic view, and this is mostly what you'll be using, I think, if you're not concerned about internals of what's happening. But you can also switch to a full view, which will show you the actual bit layout. So you can see here the data has been assigned to the first 8 bits, and sort of there's actually hidden data, which is the atom type and the ECC and things like that, if you're familiar with the MFM internals. So you can use that if you're curious about the internals of things. And down here you have the performance window. The performance window will, while it's running, show you different statistics about performance. Generally you won't be concerned about this too much. It's just going to run as fast as it can, but that could be interesting. For example, the AER is the event rates that are happening in the simulator, but the WAER, which is the wall clock AER, is showing you the speed at which you're actually seeing these things. So although the events are taking place pretty quickly at 40 AER, because there's overhead and things, it's actually running at a slower speed. So these kind of statistics are interesting. And lastly, if you get to a cool state and you want to show others what you've done, you can go to the capture window and you can click screenshot, and that will screenshot the entire screen, and that will put it into your screenshots folder. So for now it's just simple screenshots, but I'm planning to also add a video capture here as well. So that's it.